Hello everyone, welcome back. My name is Mr. Cobalt, and in this video I'm going to show you how to write the molecular complete ionic and net ionic equation for the reaction between lead-2 acetate and potassium chromate. And with that out of the way, let's get started. Okay, so we have lead-2 acetate. So the first thing you want to do is you'll notice that you have the names of the substances. So you're going to need to convert that to formulas. And I'm going to show you how that's done. Also, we're going to need to know how to go from the reactants to the products. We're going to notice that this is a double displacement reaction. So I'll show you how you can predict your possible products from the reaction itself. And then you're also going to need your solubility table or solubility rules so you can determine whether a product is formed or not, or whether a solid is formed or not. So let's get started. So here we have lead-2 acetate. So the Roman numeral tells you the charge. It does not tell you how many lead atoms or ions you have in your substance. So that's the charge on your lead. So what we need to do when you're trying to convert our names to formulas, we need to know the names of the ions. So that's given to us in the name. So lead-2 is the name of the first ion. Acetate is the second ion. Same thing here. Potassium is the first ion. Chromate is the second ion. So then we need to write the formulas for those ions and the charges. So since we know the charge is 2 on here, then that's going to be Pb for the lead, and there's a 2 plus charge on the lead. Acetate, that's a polyatomic ion. So you need to know your polyatomic ions and their charges. So your teacher's probably already told you that you need to memorize them. He or she probably gave you a some sort of chart to memorize. So you need to know those. So I have a video on polyatomic ions. So if you want to go to that one and get a refresher, please do. So here, acetate, that's going to be your C2H3O2 minus. That's the acetate ion. And so you'll notice there's a -1 charge on the acetate, and there's a 2 plus charge here. So I need 2 acetate ions to balance the charge of the lead. So I'm going to need to write 2 of these in my formula. Another way to go about this is the crisscross method, right? So the crisscross method is where you take the numbers of the charges and you write them as subscripts to the other ion. So you're crisscrossing. So I have a 1 here, so that's going to go there. So I need a 1 here and a 2 there, as I just said. So here it's going to be PB, and I need 2 of those. So I'm going to need parentheses C2H3O2 and then a 2 on the outside. So you'll notice I'm using parentheses for the polyatomic ion because I have more than 1. So please make sure that you have your parentheses for ions, polyatomic ions, that you have more than 1. If you only have 1 polyatomic ion, then you don't need to write any parentheses. So notice I have the 2 on the outside of the parentheses, so I have 2 of those. And that's it for my lead-2 acetate. So next would be my potassium chromate. So if I have potassium, that's a K. And that's a +1 charge on the potassium because it's in group 1. So remember, if you're a group 1 element, then you're going to have a +1 charge. So the rule is if you're in groups 1A, 2A, or 3A of the main group elements, then your charge is going to be equal to the charge of the number of your group that you're in. So positive charge equals group number. So if you're in group 1A, then you're going to have a +1 charge. If you're in group 2A, you're going to have a +2 charge. And so that's one way to think about it. The other way to think about it is keep in mind the elements want to have noble gas configuration. They want to be like noble gases, and noble gases have a full octet, which is normally 8 valence electrons. And remember that the number of the group that you're in is the number of valence electrons that you have. So potassium here is in group 1, so it has 1 valence electron. So it just needs to lose that 1 valence electron to be like a noble gas. So it'll lose that electron, and then when it loses that 1 negative electron, then you have a proton that is not balanced anymore, and so that gives you the positive charge. So it gives you 1 positive charge. And then the chromate is another polyatomic ion that you have to memorize, and that is CrO4, and that's going to be a 2 minus charge on the chromate. And so again, if I look at the charges I want to balance, I'm going to need 2 positive potassium to balance the -2 charge on my chromate. So I'm going to need 2 of those in my formula. So I'll need a subscript 2. You could also, again, do the crisscross method. So the 2 here goes down there, and the 1 here will go down here. And again, we don't write ones. So if I write that formula, it'll be K2 and then CrO4. And so notice, because I only have 1 polyatomic ion here, I don't have any parentheses. So no parentheses unless you have more than 1. All right, so now I have my substances. We should figure out whether they're what state they're in. Are they soluble or insoluble? Usually the reactants are going to be soluble or aqueous, but let's just check it out. So in your formulas, so it says that acetates are soluble. So there's no exception to the acetate. So if you have an acetate, it's soluble. So that's aqueous. So we're going to write aqueous here. And then what about your potassium or your chromate? So if you look in your solubility table here, it says it should say something about chromates. So it says here that all salts that contain chromate are insoluble except what? Except for group 1 elements, and ammonium, so NH4 plus. So we don't have that here, or we do actually have. We have a group 1. So potassium is group 1, so that means that this is insoluble. So chromates are generally insoluble. I keep mixing it up. So they're generally insoluble, but in the case of having a group 1 metal, it's going to be soluble. So here we have soluble, so aqueous. So now we have our reactants. So now we need to figure out what our products are. And so you'll notice you have 2 ionic substances as reactants. That's a dead giveaway that you've got a double displacement reaction. So you need to figure out the products from the double displacement reaction. What does that mean? It means that you're going to put the inside ions together. So the potassium and the acetate are going to go together to form one product. And then the outside ions are going to come together. So your lead and your chromate are going to come together to form products. So all you do is you put those ions together, make sure you balance the charge so you get the correct formula, and then we'll go for there. So the lead-2 ion and the chromate both have 2 charge. So this is a +2, this is -2. So I only need 1 each to balance the charge. So it's 1 to 1. So that means that I'm going to have Pb and then CrO4. So that's the formula for lead chromate or lead-2 chromate. And then the inside ions go together. So my potassium and my acetate are going to go together. Potassium has a +1 charge. Acetate has a -1 charge. So it's 1 to 1 again. So that's going to be K C2H3O2. Okay, so those are my 2 possible products. So now once we have the products here, we can balance the equation. So I have 1 lead, 1 lead. I have 2 potassium. I only have 1 potassium here, so I'm going to need a 2 coefficient. Notice I'm not changing subscripts. So once you have the once you have the correct formulas, you're not changing subscripts because that'll change the formula, and you don't want to do that. So when you're balancing your equation, you only use coefficients. You only change coefficients. So I have 2 potassium, 2 potassium. I have 2 acetate ions, and here I have 2 acetate ions because I have a 2 there. And now I have 1 chromate ion, and I have 1 chromate ion. So this is a balanced equation. Now, the last thing we need to do is figure out what the state these are in. So let's look at our chromate. So the rule was, again, that chromates are insoluble. Chromates are insoluble unless you have a group 1 element, or if you have a group 1 metal, or if you have a ammonia. So here we do not have a group 1 metal. We don't have ammonia. So this is insoluble. So that's going to be a solid. And again, acetates are soluble in general. There really are no exceptions to acetate substances. So if you've got an acetate, it's soluble. So that's going to be aqueous. Okay, so now that we have our balanced molecular equation, so we have our balanced molecular equation. Why is this a molecular equation? Because we're writing our ionic substances as if they're molecules. We're putting the formulas together. But in reality, ions in the aqueous state are floating around doing nothing. They're separated from each other in reality. So that's where the complete ionic equation comes in. That's where we're going to separate out the ions. So if we separate out the ions, this is aqueous, so we separate out the ions by writing them separately. So Pb, and we're going to write the charge. So when you have them as separate ions, you write the charge. So this is going to be Pb 2 plus aqueous plus, and then you've got 2 acetates. So the subscript becomes the coefficient. So we're going to have 2 C2H3 O2. And the reason for that is because if we write the 2 down here, that's gonna indicate that the 2 acetate ions are together, but they're not together, they're separate. So we write it as a 2 coefficient. And so we have aqueous here, and there we have to have the charge minus. So that's that one. And so we do the same thing for this aqueous. So we have 2 potassium. So I'm going to have 2K plus aqueous. And then plus, and then we have our chromate. So that's going to be 1 chromate, CrO4, 2 minus aqueous. And so now we've separated all the ions in our reactants. And then we do the same thing over here. Now notice we have a solid here. We don't separate solids. So if you have a solid, liquid, or gas as a product, don't separate those. So here we have a solid, so we're not going to separate the ions here. We're just going to rewrite it as a solid. So here we have PbCrO4 solid. And then for these two, we're going to separate the ions. So we have 2 potassium plus, so 2K plus aqueous plus, I'm going to have to write this down here, we have 2 acetate ions. So 2 C2H3O2 minus aqueous. Okay, so this is our complete ionic equation. So all of the ions have been separated that are aqueous except for the solid. So now the thing to keep in mind is that this is a complete ionic equation. And so now we need to figure out what the net ionic equation. And so here we're paying attention to what the players are in the reaction. So when you're doing your net ionic equation, the difference between your complete and net ionic equation is that you've removed the spectator ions. Okay, so removing the spectator ions makes your net ionic equation. So we need to figure out what the spectator ions are. The spectator ions are the ones that are not involved in forming your products. And so here we see that you are forming a solid here. So the ions involved in this solid are the ones who are playing the game, if you will. So these are the ones involved in the reaction. The rest of them are not involved. So those are your spectator ions. So they're spectating, they're watching, they're not involved in the reaction at all. So the other way you could think about it is anything that stays in the same state on both sides are spectators. And if you have the same number as well. So here I have lead in the aqueous state, but here I have it as a solid. So that changes. So that is a player. Here I have two acetate ions in the aqueous state. Here I have two acetate ions in the aqueous state. So that is a spectator ion. So we're going to get rid of the spectator ion. So the acetate ion is a spectator. And you'll notice I have two potassium aqueous and I have two potassium aqueous. So that is a spectator. And so what's left over is your complete or your net ionic equation. So here, all I do is rewrite whatever is left. So I have Pb2 plus aqueous plus I have my chromate CrO4 minus aqueous, and that's going to form my PbCrO4 solid. And so this is my net ionic equation. And so this is what's left. So I hope this was helpful. If you enjoyed this video, if this helped you out a lot, then please make sure you like the video, put a comment in the comment section, let me know what you think, and if you have any other questions. And please subscribe to my channel. So hit the subscription notification bell so you can be notified of any new videos I put out. Thanks for joining me and have a great day.